morning children. In today's class, we are going to learn about Taylor series and Maclaurin series. When can I use these series? See, for example, if I take x square, first derivative of x square is 2x. If I find one more derivative, it is 2. If I find one more derivative, it is 0. So, when I take x square derivative first time, second time, third time itself, it terminates. It is over. After that, every derivative will become only 0. There are terms like e power x. First derivative, e power x. Second derivative also e power x. Third derivative also e power x. So like this, unending it goes. So functions which are infinitely differentiable, we can apply Taylor series and Maclaurin series. Maclaurin series is a milestone in calculus, I can say, because we know various definitions for sine, cos, tan inverse, e power x, log x, like that. All these functions, I can simply write an expansion like this in terms of x, higher powers of x, that's it. So all the functions that we know, which are infinitely differentiable, I can easily write as an expansion in terms of x. And that is the very importance of Maclaurin series in the idea of calculus. Consider a function f of x, which is infinitely differentiable at x is equal to a. Then f of x can be expanded as a series in an interval x minus a to x plus a. From x minus a to x plus a. That is the interval where a is the point where it is infinitely differentiable. We can write f of x like this. Sigma summation n equals 0 to infinity f nth derivative of a by n factorial into x minus a power n. So the entire series, I have powers of x minus a. The very first idea, put 0. X minus a power 0 is 1. 0 factorial is 1. So I simply get f of a. After that, it is simple to remember. X minus a power 1. F first derivative at a, 1 factorial. X minus a power 2. F second derivative at a by 2 factorial. So like this I can expand, and in general the nth term may be f nth derivative at a by n factorial into x minus a power n, and it goes on and on up to infinity. The same series, when a value is 0, we specialize it and call as Maclaurin series. So Maclaurin series, the same idea we are going to write, but wherever a comes, we are going to put 0. So how do we read it? F of 0 plus f dash of 0 by 1 factorial into x plus f double dash of 0 by 2 factorial into x square, f triple dash of 0 by 3 factorial into x cube, and so on. If you need, you can write the nth term, that is f nth derivative at 0 by n factorial x power n, and so on. When we say theorem, we stop with nth term because theorem should be well defined. But when I say series, it may go on and on up to infinity. So this exercise, we are going to do problems based on Taylor series and Maclaurin series. Exercise 7.4, question number 1. Write the Maclaurin's expansion for e power x. The given question, call it as f of x. Find the next derivatives, f dash of x. E power x is the simplest problem where every derivative is e power x only. First derivative e power x. Second derivative also e power x, third derivative also e power x, and so on. Wherever x is coming, put 0. F of 0, e power 0, that is 1. F dash of 0, e power 0, that is also 1. Double dash of 0 is also e power 0, that is 1. F triple dash of 0 is also e power 0, which is 1, and so on. We remember Maclaurin series f of x equals to f of 0 plus f dash of 0 by 1 factorial into x plus f double dash of 0 by 2 factorial into x square, and so on. Substituting the values here. What is f of x in this question? It is e power x. What is f of 0? 1. F dash of 0 is also 1 by 1 factorial into x, 1 by 2 factorial into x square, 1 by 3 factorial into x cube, and so on. Every value is 1 only in this problem. As I rewrite it, I can write 1 plus x by 1 factorial, x square by 2 factorial, x cube by 3 factorial, and so on. And this is the expansion for e power x. Exercise 7.4, question number 1, subsection 2. Write the Maclaurin's expansion for sin x. The question is sin x, so call f of x equals sin x. First derivative, sin x becomes cos x. The next derivative, f double dash of x. Cos x will become minus sin x. The next derivative, minus as it is, sin x will become cos x. I can write one more derivative. A fourth derivative of x is minus cos x will become minus sin x. Already one minus, so plus sin x, and so on. Wherever x is coming, put 0. Sin 0, 0. Remember the values. Cos 0, 1. Minus sin 0, 0. Minus cos 0, minus 1. And so on it goes. Substitute the values. The fourth derivative again, it is sin 0, that is also 0. We can write one more derivative also because so many zeros are coming. Try to achieve at least 3 non-zero values. So fifth derivative, I can say sin x becomes cos x. Fifth derivative at 0, cos 0, that is 1. Remember the Maclaurin series formula, substitute. What is f of x? It is sin x equals to f of 0, the value is 0. F dash of 0, it is 1 by 1 factorial into x. Double dash, it is 0 by 2 factorial into x square. Triple dash, it is minus 1 by 3 factorial into x cube. Fourth derivative, 0 by 4 factorial into x power 4. Fifth derivative, plus 1 by 5 factorial into x power 5, and so on. So how do we simplify the answer? Removing all the 0 terms, sin x equals to x by 1 factorial. This is 0, forget it. X cube by 3 factorial plus x power 5 by 5 factorial, and so on. As I see the first 3 terms, I can always guess what may be the remaining. Look at the numerators. Power 1, 3, 5. What would be the next power? 7, then 9, then 11. So all the odd powers will come. The denominator, when the power is 1, denominator 1 factorial. The power is 3, denominator 3 factorial. The power is 5, denominator 5 factorial, and so on. So I can easily guess whatever is the power comes in the denominator as factorial, and only odd powers come for the expansion of sin x, and that is the answer. Supposing you try for cos x. Almost the same pattern, but now we will get all the even powers. So sin x expansion, only the odd powers are coming, whereas cos x expansion will have only the even powers of x. Try it and check whether you get it. Subsection 3, cos x. F of x is cos x. First derivative, cos x will become minus sin x. Minus sin x will become cos x. Minus cos x will become minus sin x. Already one minus, so plus sin x. Fourth derivative, sin x will become cos x. Fifth derivative, cos x will become minus sin x. And the derivatives go on and on. Now, wherever x comes, let us put 0, cos 0, the value is 1, sin 0, 0, cos 0, here the symbol is minus, it is minus 1, sin 0 is 0, fourth derivative cos 0, 1, fifth derivative sin 0, 0, and it goes on and on. Maclaurin series, as we remember, f of x equals f of 0 plus f dash of 0 into x by 1 factorial plus f double dash of 0 by 2 factorial into x square plus f triple dash of 0 by 3 factorial into x cube, and so on. Here the function is cos x equals to f of 0, the value is 1, plus f dash of 0, 0 into anything 0, forget it. F double dash of 0 minus 1 into x square by 2 factorial plus f triple dash of 0 into anything 0, forget it. Fourth derivative plus 1. Fourth derivative tells me by 4 factorial x power 4. Fifth derivative is also 0, and so on. How to simplify the answer? Cos x equals to 1 minus x square by 2 factorial plus x power 4 by 4 factorial minus, and so on up to infinity. As we see the terms, you can guess the next terms. We have only even powers, 2, 4. What would be the next term? X power 6. The next term, x power 8, and so on. Denominator, 2 tells me 2 factorial, 4 tells me 4 factorial. So 6 would tell me 6 factorial, and so on. Cos x, we have the expansion, and that is the answer. Subsection 4, write the Maclaurin's expansion for log 1 minus x. F of x equals log 1 minus x. It needs to be positive. Log is defined only for the positive values, and that is why minus 1 less than or equal to x less than or equal to 1 is given. So that when x is in this range, 1 minus x is always positive. Log of positive values is defined. Well, we shall proceed. F dash of x. Log will become 1 by 1 minus x, and then hide logarithm. 1 minus x will become 1 is a constant. It will become 0. Minus x will become minus 1. So what is my answer? Minus 1 by 1 minus x. Second derivative. Minus whenever the denominator power is 1. We will remember 1 by x. The formula is minus 1 by x square. Applying that, this minus symbol I have retained. 1 by 1 minus x by this formula minus 1 by 1 minus x the whole square. Because 1 minus x is coming, 1 will become 0, minus x minus 1 should come. So ultimately minus into minus into minus minus 1 by 1 minus x square. The same idea, we go on to the next derivative. When it is negative, I will write the next term to be positive. Cross multiply. Cross multiply. Minus 1 by 1 minus x the whole square. That is the formula. When I cross multiply 1 into 2, 2 by 1 minus x the whole power 3. We actually use this formula. X power n derivative is n x power n minus 1. Applying n value this, we get the answer. But 1 minus x comes, my answer will become minus 1. Whenever minus x is coming, after applying the formula, put this minus 1. Chain rule. So plus into minus minus. 2 by 1 minus x the whole cube. What is the next derivative? Again, it is minus. So applying the formula, it will become plus 2 3s are 6 by 1 minus x the whole power 4. Because 1 minus x is coming, minus x tells me minus 1. So my answer is minus 6 by 1 minus x power 4. And the derivative goes on and on. Now, wherever x is coming, let us put 0. F of 0 is log 1 minus 0. Log 1 is 0. F dash of 0, we substitute here. Minus 1 by 1 minus 0, that is minus 1. F double dash of 0, minus 1 by 1 minus 0 square, that is again minus 1. Triple dash of 0, minus 2 by 1 minus 0 cube, that is minus 2. Fourth derivative of 0, minus 6 by 1 minus 0 power 4, that is minus 6, and it goes on and on. Let us remember Maclaurin's expansion. What is the expansion? See how we write it. F of x is equal to f of 0 plus f dash of 0 into x by 1 factorial, f double dash of 0 into x squared by 2 factorial, f triple dash of 0 into x cube by 3 factorial, and so on up to infinity. Here f of x is log 1 minus x equals to f of 0, the value is 0, f dash of 0 minus 1 by 1 factorial into x, double dash of 0 minus 1 by 2 factorial into x square, triple dash of 0 minus 2 by 3 factorial into x cube. The next answer minus 6 by 4 factorial into x power 4, and so on up to infinity. Since 1, 2, 6 numbers are coming, let us expand. What is 1 factorial? 1. What is 2 factorial? 1 into 2. What is 3 factorial? 1 into 2 into 3. What is 4 factorial? 1 into 2 into 3 into 4. Simplify and write it. So I get log 1 minus x equals to 0, will forget it, minus x. Minus x square by 2. 2 and 2 cancels, minus x cube by 3. 2 3s are 6 cancels, minus x power 4 by 4 and so on up to infinity. Can you guess the next terms? It is x square, x cube, x power 4. What would be the next terms? X power 5, x power 6 and so on. Denominator. When the power is 2, denominator is 2. When the power is 3, denominator is 3. When the power is 4, denominator is 4. So when the power is 5, denominator will be 5. Power is 6, denominator is 6. So I am able to guess the next terms, and that is the ultimate use of writing the expansion. Subsection 5, f of x equals tan inverse of x. X ranges from -1 to +1, so that this will be a well-defined function. F dash of x, tan inverse, we should know the formula 1 by 1 plus x square. Derivative of tan inverse x is 1 by 1 plus x square. If I differentiate this, it will be leading to complicated terms. So this 1 by 1 plus x square, we refer to another Maclaurin's expansion. When it is 1 by 1 plus x, what is the next derivative? 1 by x will become minus 1 by x square. Here it is 1 plus x. Minus 1 by 1 plus x the whole square. How to go on to next derivatives? Alternatively, positive, negative. Increase the powers in the denominator. Cross multiply. 1 2s are 2. 2 3s are 6. Like that it will go. Putting x value 0, all the denominators give me 1. So all the numerators will be my answer. Putting them in Maclaurin series, we get 1 by 1 plus x is 1 minus x plus x square minus x cube and so on. Applying 1 by 1 plus x expansion here. Instead of x, we have x square. So the same expansion, but wherever x is coming, put x square. 1 by 1 plus x square will become 1 minus x square power 1 plus x square power 2 minus x square power 3 plus x square power 4 minus x square power 5 and so on up to infinity. Expanding this and writing it in the proper way. 1 minus x square plus x power 4 minus x power 6 plus x power 8 minus x power 10 and so on. Find the next derivative. Now it is simple to differentiate. Remember the formula. X power n derivative is n x power n minus 1. Applying that here, 1 being a constant, it will become 0. X square, 2 x power 2 minus 1 is 1. 4 x power 4 minus 1 is 3. Minus 6 x power 6 minus 1 is 5. Plus 8 x power 8 minus 1 is 7 and so on. The next derivative, 0 you forget, minus 2, x will become 1 plus 3 4s are 12, x, 3 comes, the power will be 3 minus 1, 2, minus 5 6 are 30 x power 4 plus 56 x power 6 and so on. Next derivative, minus 2 will become 0. 12 2s are 24x minus 120x cube. 6 into 56, 336 x power 5 and so on. The next derivative, 24 minus 360 x square plus 1680 x power 4 and so on. As we know around 5 derivatives, we can put and so on. Find out the derivative values at 0. F of 0 is tan inverse 0, that is 0. F dash of 0, here I have to substitute 1. All the remaining terms will become 0 because x is 0. F double dash of 0, fully containing x. X 0 tells me the entire expression becomes 0. F triple dash of 0, minus 2, the remaining terms will become 0. F fourth derivative of 0, fully containing x, so it will become 0. Fifth derivative of 0, 24, and the remaining terms containing x, so it will become 0 and so on. Now we will write the Maclaurin's expansion. So Maclaurin's expansion, as we know, it is f of x equals f of 0 plus f dash of 0 by 1 factorial into x plus f double dash of 0 by 2 factorial into x square plus f triple dash of 0 by 3 factorial into x cube and so on up to infinity. We shall substitute the values. What is f of x? F of x is tan inverse of x equals to f of 0, 0 plus f dash of 0, 1 by 1 factorial into x plus 0 by 2 factorial into x square minus 2 by 3 factorial into x cube, 0 by 4 factorial into x power 4, 24 by 5 factorial into x power 5 and so on up to infinity. We have just substituted the values from here. As I write down the factorial expansion, I get tan inverse x equals x by 1 factorial is 1. 0 into anything 0, forget it. 2 by 3 factorial, 1 into 2 into 3 x cube. This is 0, forget it. 24 by 5 factorial, 1, 2, 3, 4, 5 into x power 5 and so on up to infinity. We can rewrite the answer x minus x cube by 3 plus 24, 1, 2, 3, 4 will get cancelled, x power 5 by 5 and so on up to infinity, and you can guess the next terms. Power 3, denominator 3. Power 5, denominator 5. Next term would be x power 7 by 7, x power 9 by 9 and so on. And alternatively positive, negative. So once you write 3 terms, you can easily guess the remaining terms yourself. And that is the beauty of writing Maclaurin's expansion for any given term. Subsection 6. Write the Maclaurin's expansion for the function cos square x. Take f of x is cos square x, f dash of x. Remember the formula x power n. The derivative is n x power n minus 1. So x square will become 2x. In the same way, cos square x will become 2 cos x. X square becomes 2x. In the similar way, cos square x will become 2 cos x. Hide square. We are left with cos x. Cos x will become minus sin x. So this we call chain rule. Cos square x will become 2 cos x. Hide square, cos x will become minus sin x. Trigonometry, we have learnt 2 sin A cos A is nothing but sin 2A. Applying this formula in this step, we get f dash of x is equal to minus sine 2x. Second derivative, sine will become cos 2x, 2x will become 2. The next derivative, already there is a minus 2. Cos 2x will become minus sine 2x. Again 2x will become 2. Remember, this is also chain rule. Whenever you have 2x in the question, sine 2x, the derivative, sine will become cos 2x dash. So inside 2x will become 2. Similarly, cos 2x derivative when I do, cos will become minus sine 2x. 2x is coming, so that will become 2. So remember these simple formula to apply in these exercises. If I multiply, it is 4 sine 2x. The next step, 4 comes as it is. Again sine 2x. Sine 2x will become 2 cos 2x, which is 8 cos 2x, and the derivatives go on and on. Wherever x is coming, put 0. F of 0. Cos square 0, the value is 1. First derivative minus sine 0. Sine 0 is 0. Second derivative minus 2 cos 0. The value is minus 2. Cos 0 is 1. So it is minus 2. Triple derivative 4 sine 0, that is 0. Because sine 0, 0. 0 into 4 is 0. Fourth derivative 8 cos 0. 8 cos 0 value 1. 8 into 1 is 8, and so on. As we substitute in Maclaurin series, f of x, we write cos square x. F of 0, 1. F dash of 0, 0. 0 into x by 1 factorial. F double dash of 0, minus 2 x square by 2 factorial. F triple dash of 0, 0 x cube by 3 factorial. Fourth derivative 8 x power 4 by 4 factorial, and so on up to infinity. Since we have some numbers here, we can expand the factorial and write. So the next step, cos square x equals 1. 2 and 2 cancels, minus x square. 0 into anything 0. 8 x power 4 by 4 factorial is 1, 2, 3, 4, and so on up to infinity. As I cancel 2 and 4 with 8, my expansion is 1 minus x square plus x power 4 by 3 minus, and so on up to infinity. As we have done a few problems in Maclaurin's expansion, now that you should have an idea, whatever be the question, whether it is e power x or log x or cos or sine or inverse, any function can be expressed as an expansion only in terms of the powers of x, and that is the beauty of this expansion, which is a great milestone in the idea of calculus. Thank you.